Okay, so we have this now arranged in the correct order of cooling. We said that granite cooled the slowest, as we can tell by the visible crystals. Which one of these do you think is going to be the densest? That is the heaviest per unit. Yes, same thing, right? Mm-hmm. So there's three areas that we can identify for cooling. Intrusive, extrusive, and volcanic. Intrusive, being that it cooled inside the earth. Extrusive, meaning that it cooled on the outside of the earth. Volcanic, meaning that it cooled as the result of a volcanic eruption, right? So, of these, which one do you think is intrusive? Granite is right, because we know that it cooled the slowest. Since it cooled the slowest, we would expect to be insulated from the Earth's surface temperature, so it cooled inside the Earth. What about the basalt? Where do you think it cooled?
Inside.
Intrusive, extrusive, or volcanic?
Intrusive.
I think intrusive, right?
Actually, extrusive, okay? And the reason is because we cannot see the crystals, okay? So we know that it cooled quickly, all right? These two, though, cooled by volcanic. How do we know they cooled by volcanic?
They have holes.
They have holes. They're frothy, right? So these are called vesicles. Could I get the camera to come and look at these rocks, please? These vesicles are air bubbles that cooled as the rock was crystallizing. So it cooled so quickly that the air bubbles remained in the rock. How can we tell which one of these cooled quicker?
The size of the air bubble?
Well, and the air bubbles, but we said that this is the most dense, right? How can we tell which one of these is going to be cooling faster? The least dense or the most dense?
Least dense.
Least dense is right. How are we going to test the density? I just happen to have a glass of water. Pumice is the only rock that floats on water. You want to give it a shot?
Yeah.
And as you can see, it does. So this is another fantastic tactile lesson plan for students who won't believe that any rock will float on water. Pumice is a volcanic rock that cooled immediately upon explosion, upon the volcanism. Because it cooled so quickly, it preserved so many air bubbles in its structure that it is lighter than water. It's actually buoyant. So these are some physical characteristics of the rocks that let you decide how fast they cooled and therefore where they cooled, either under the Earth's surface, at the Earth's surface, or during a volcanic event.